Today's 2.2. Again, a brief recap of yesterday because we're still solving equations. This is titled More Equations. An equation is any algebra sentence that has an equals in it. These equations, they're like a scale. They're balanced out. We need to keep them balanced by whatever we do to one side, we match that same thing on the other. We're still looking to do opposites. But there's some shortcuts, some tricks, and just some new different problems today compared to yesterday. So the first thing, you don't have to do this, okay, but there's an option in fraction equation solving that's called clearing the fraction. If you don't like fractions, this is going to be a trick for you. If you don't mind fractions at all, you can just live with the fractions. I skipped an x on this. Here's my x going, here's an x. So if you wanted to just jump in and do opposites the way we did yesterday, since this is adding 3/4, you could go ahead and subtract 3/4 and make common denominators and do stuff with that, and that'd be fine. And after you did, you could divide by this fraction and flip it. If you're a fraction genius and you're comfortable with all of that, feel free to do it. Later in the year, there's going to be some stuff where there's more variables than this, and this will be an unavoidable trick to do other problems in our future. So you might want to just absorb this now. Is what we'd like to do is go through each of these terms and multiply by the LCD, the least common denominator, or the least common multiple if you prefer LCM. But you look at the bottom, 8, 4, 3, find some number they all can go into. 8, 4, and 3 can all go into a 24. If it makes you feel more comfortable, you could put the 24 on top of a 1, but I don't really feel like doing that. The 24's job in life is to make these bottoms all cancel, and it's probably going to change the tops. Okay, in this case, it will change all the tops. So here, 24 cancels 8, and there'd be 3 left of the 24, because 8 into 24 goes 3 times. That multiplies the top to get 9 next to x. Then do the same thing. 4 cancels 24 to get you 6. 6 multiplies to make a new top. 3 cancels 24 to make 8. 8 multiplies the top. Don't lose track that that was negative and just bring your sign with you. And more people are going to be more comfortable with this than they were with that now that it's time to just do our opposites. But if you were comfortable on that, that's fine. But someday coming, this is going to be a thing you have to do. To multiply everything by that common denominator to get a nice cancel of all the bottoms. Opposite time, we're going to subtract 18, and I'll cut you some slack on the work today. I'd want to see this. If you want to continue to write the minus 18s and cross out the 18s, feel free, but I'm no longer going to require that of you. But I would like to see the next line where 9x is left standing. You've already subtracted the 18s, and you get negative 34. And then a solution line with x equals negative 34 ninths. I'm not going to require you to plug that back in to check anymore either, but if you have a calculator that does fractions, that's a decent investment of $10 or $15 to go fraction times fraction on your calculator, add another fraction, see if it equals that. It will. It's not a bad idea. Second category, we're going to clear decimals. Okay. Over here, what we did was legal again, because we multiplied on this side, but we multiplied on this side. We did the same thing on both sides. What we're looking to do is a similar idea here. When there's decimals involved, if you multiply by like tens or hundreds or thousands, things with lots of zeros, it moves the decimals over. So what we're going to look to do is multiply both sides, everything, by one of those kind of numbers to move all the decimals to the right so that they're at the right end. So this decimal would like to move 2. This decimal would like to move 1. The longest decimal we have is 2 decimals worth, so we're going to slide those all over 2 decimals worth. So this would be 123. This, when you slide it over 2 spaces, would be 270. And if I do that and stop there, I'm wrong. So if in the home audience, see if you can figure out what I just did that was wrong. I'm supposed to move these all over 2 places. I did not successfully do that. I did stuff on the left. I didn't do anything to the right. Okay. Remember, this has an invisible decimal. So whether this had appeared on the left or right, it doesn't matter. But if there's whole numbers for this trick where we're moving decimals over, you need to recognize there's an invisible decimal to move twice, and that's going to create a couple zeros in that number. The decimals all have to move the same amount. Then start doing opposites. I'm not going to do anything to the multiply divide stuff until the end. I'm going to subtract 123 to get that out of there. It's a positive 123, so that's a subtract to kill it. This has nothing to do with subtracting. That's just coming with us right now. So subtract 123 to get that gone. If we subtract 123, we have this. When we go to divide, negative dividing negative is positive. 323 over 270. It's worth thinking for a second if that could reduce. 3 rule is a good rule to know. Numbers are divisible by 3 if you add up the digits. Like 2 plus 7 plus 0 is 9. 3 can go into this. 3 can't go into this though, because 3 plus 3 is 8. 3 plus 3 is 6, plus 2 is 8. So 3 can't go into that. I don't know if anything can go into 323. 17 can 19 times. So 17 and 19 go into that. 17 and 19 go into this. That's not reducible, that's just done. But anytime you get a fraction, think about reducing or invest $10, $12, $15 in a calculator that can reduce fractions, and let that do that for you. Third trick, instead of distributing, sometimes you can divide. Okay, this is set up to do that because 5 can go into 20. This is legal because distributing is a type of multiplying. We're trying to do the opposite. We'd like to divide. If we divide this side by 5, it just cancels the 5 to leave 2x plus 3. If you divide this side by 5, you get a 4. And I don't need the parentheses anymore. If you didn't notice that and you distributed, no harm. Just when you distribute, you make everything bigger. Whereas when you divide, you make everything smaller. This will be easier to solve. Subtract the 3 from the 4 to get a 1. Divide by the 2, you get a half. And I'd like to see these in between steps. There's more work you could show that I made you show yesterday. I'm letting you off the hook for that. But I do want to see, like, step by step what happened. Show the divide step, do the one opposite, do the other opposite. I'd like to see that. If this 20 were a 21, you'd be out of luck. You wouldn't want to try to divide 5 into 21, I don't think, because then you'd either get a fraction or a decimal, and it's not probably worth the hassle. If this number that wants to distribute can't divide into that one, just distribute and go. This doesn't have any kind of trick. This is just a bigger question than yesterday. So we're still solving equations. We just work in an extra step. I think yesterday we had a 5-step plan that started with combining like terms. If you wanted to redo a 6-step plan today, distributing is above that on the list. Parentheses need to happen first. So here we want to distribute this. Be careful of the minus that we switch all the signs that are coming to not only a negative with the 8x, but also minus that's going with the 8. Then, like terms, 10 minus 8 is a 2. I'll leave the rest of this alone. So distribute is 1, like terms is 2. Having a variable on each side to manage that is 3. So if I want to get rid of this, I'd add 12x. That is what I'm going to do. To get rid of this, I'd add 8x. That's not what I'm going to do, because adding 8 would still leave this negative, and I'm going to try to avoid negatives. So if I add 12x to get rid of that, there's still an 18, there's still a 2. But adding 12x to one side adds 12x to the other side, and now that's a positive 4x, because positive 12 beat negative 8 by 4. Now add subtract stuff next, so adding 2 makes me subtract 2. If I do that to one side, I do it to the other. And then the final move would be to divide 4, and the x would be 4. We could plug that in and check, it would work. In class, you rarely see the value in checking, because I don't usually mess up, unless like on purpose I mess up. I will occasionally you'll catch me, but for the most part I should be able to do these right, because it's my job. But on your papers, homework, quizzes, tests, you're going to get more mistakes than you're going to see me make, most likely. So checking is valuable. Sometimes class just deceives you on that. The last topic, which is a whole different topic, is a special kind of equation. If you look through the rest of the notes, you can see all of these problems, they all equal 0. And they're all involving multiplications. And there's a special rule for this situation. If you're going to multiply and get 0, the only way you can ever multiply and get 0 is if 0 is involved in the problem. You can't have a 0 answer for multiplying unless 0 is one of the factors. So they're going to set up a bunch of problems at the end. One thing times another is making 0. It has to be the case that either that first piece is 0, or that second piece is 0, or in an unusual circumstance sometimes, maybe even both of them were 0. 0 times 0 is 0. So if this times this makes 0, one way you could do this is just take each piece on like a little bit of a walk. Take the x plus 2 piece on a little bit of a walk over here. X plus 2 equals 0. Do an opposite, solve that up, subtract the 2. This x would end up being -2. -2 is one of those answers. Take the x minus 7. Go on a walk. Let that equal 0. Do a little bit of math on that. Do an opposite, add 7, you come up with 7. You've done that before. You might remember this, what I'm about to say already, or maybe you figured it out as you took those walks, is the only thing that happens when you take one of these on a walk and it equals 0, and you do the opposite, you're going to get back the same numbers, but the signs are going to flip. So an x plus 2 is going to give you a -2. An x minus 7 is going to give you a +7. It's just how that's going to work. So if we go to do this one, I'm not going to take the walks. I'm just going to see x plus 3 and go -3. I'm going to take x minus 4 and do a +4 and just be done with that. If I stuck something out here like an 8, that does absolutely nothing. Okay? This can be made to equal 0 depending on our x choice. This can be made to equal 0 depending on our x choice. These answers still stand. There's no way to make this 0. It's 8. It's stuck. If I do a variable out here, now that gives us another option. If I do a variable out there, this I can make 0 by choosing 7. This I can make 0 by choosing -2. This I could make 0 if I chose 0. Okay? Anytime there's an x out here or a power of x out there, 0 is going to be in our answer list. So sneaking ahead a column. This is going to give us 2 answers. One from here, one from there. 0 from this, from what we just talked about. -8 from that, from flipping the sign. This is going to give us 2 answers. One from this, that's still 0. Any x, even to any power, is just 0. Because 0 times 0 times 0, no matter what the power is, that stuff is 0 if we choose 0. This, flip the sign, there's a 9. This doesn't have 2 answers. This is worthless. 2 is 2. 2 can't be changed. This is the only thing that can take on a 0 value with a -5. This has 2 answers because there's 2 pieces. Now maybe here we need to take a walk if people forgot. If you forget how to do this, take 2x plus 3 on a walk. And this whole idea is based on equaling 0. Subtract that 3. Divide by the 2. -3/2 is a winner. So what's going on with this is we got used to sign change, sign change. We're still doing a sign change. +3 became -3. But then the number with the x is going to always end up on the bottom. So this 3x plus 4 is going to involve a -4 from a sign change, but on top of the 3. If you don't believe it or want to know why, again, just take it on a walk. 3x plus 4 goes on a walk. Everything today equals 0 once we get into this last homework section. Subtract the 4, and that's why the sign changes. Divide by the 3, that's how the 3 ends up on the bottom. It's always sign change for top, number with x to the bottom. So this will have 2 answers. This we're going to go sign change for +7 for the top, on top of the 5. For this one we go sign change on the 3 for the top, divide by the 8. This last one's going to have a triple answer. The x plus 4 just needs a sign change. The 5x minus 1 needs the sign change on the 1, and then the 5 to go down. Any power of x hiding out there makes a 0, and the 3 is just worthless. That's everything from 2-2, so we're working homework page 63 from 1 to 30. Send me an email if you have questions. We can set up Zoom questions to get interactive and answer questions. I'd highly encourage you on these assignments, check all the odds in the back. If you're getting the odds right, honestly, you're getting the evens right. It's not like you're going to miss the odds or get the odds right and miss the evens. It's the same difficulty of questions. So let the odds in the back, use those answers as your guide to feel confident about what you're doing.